All right, welcome everyone. We're going to give it a few minutes for people joining. We have a ton of people joining. The attendee count is rising. So we'll give it 30, 45 seconds here, let people get logged in, get their audio working, and then we'll get rolling. All right, about a minute after, we got pretty good number of attendees. Thanks for joining. We'll get things kicked off here. Welcome to another Webinar Wednesday. A little introduction. I'm Damon Thompson. I manage the US product team as well as the advanced applications team. And I'm very excited to actually be kicking off the final webinar of 2025, kind of brought to you by Beckhoff US and with some speaker from ETG, Martin Rostan, which we'll introduce in a second. And before we get into today's topic and the presenter, I wanted to mention some of the ones that we've done before. So we launched this Webinar Wednesday series back in October of 2024, with the first actually topic was Brandon Stifler on software development tools and automation. And as you can see on the slide, we've covered a huge range of topics since then, of different products and technologies. If you've missed any of these webinars, the recordings are available for download. You can see the link down in the bottom right-hand corner, and we could drop this in the chat window later on as well. You can also access with that QR code for the on-demand webinars. This one today will also be available on demand probably sometime later this week. But if you missed any of those, check them out. There's some pretty good content there. So for today, I'm pretty excited about today's topic and presenter. So we'll do a little introduction there. So today's topic is on EtherCAT and meeting cybersecurity needs. And really with any form of communication technology, security is always an important topic. And with the new standards such as, standards and laws such as EU Cyber Resiliency Act, this is becoming even more important. And not just for kind of the communication nerds, but honestly, anybody in the industrial automation space, this is an important topic. And who we have presenting this topic today is Mr. Martin Rostan. And Martin has really been in this industrial communication space his entire professional career and really has a passion for this technology and kind of convincing and working on this technology to further it in the automation space. Martin's also been with Beckhoff since 1998. Currently acting as Senior VP of Marketing, of Technology Marketing. And since 2003, Martin's really been active and stood for EtherCAT and the EtherCAT field bus, which has become, really the world standard. There's worldwide acceptance thanks to its outstanding performance, the simple handling, the constant openness. And Martin's currently overseeing the entire kind of EtherCAT Technology Group as the executive director and president. Before this, on the communications front, Martin worked on and really led the EU research project that built the original CAN open specification that I'm sure you guys in the automation space are well aware of, and was responsible for disseminating that technology and is still actually the chairman of the CAN Open Interest Group or the CAN and Automation Association. So that's pretty cool. Involved a lot of things. EtherCAT's also led him to join a lot of industrial standardization efforts, including technical expert on committees such as IEC committees and ISO committees and SEMI standards. And he continues to really give the knowledge and disseminate this knowledge of field buses and Ethernet technologies through white papers, conferences, journals, even textbooks. So I'd like to introduce Martin. I know maybe he doesn't look as good live as he does in that picture. That picture's about 3 years old, and I think he looks a little fresher. But anyway, it's the end of a day before a Christmas party there in Nuremberg. So I'll hand it over to Martin. He can get us started on the topic. Welcome, Martin.
Thank you, Damon. And yeah, we talk about EtherCAT and cybersecurity today. And I have a lot of slides, so I have to get started right away. This is what I've prepared. We will start with looking at the Cyber Resilience Act. Of course, that's European Union law, not US law, but I'll show you why this affects you as well. And by the way, there's similar legislations coming up in your part of the world as well. So the Cyber Resilience Act tries to, of course, improve the cyber security of products. It was enforced or started in December last year. And we have a 3-year grace period for products, but a 2-year grace period for reporting. Actually, it's less than 2 years. It's looking at products with digital elements that includes hardware and software. And everybody who is making products available in the European Union is affected. This means importers, distributors, manufacturers, anybody who brings a product to the European Union. It does not apply to medical devices, vehicles, aircraft, marine equipment, not to open source, and not to defense products. For those, there are other directives and regulations in place. Just a little bit of background of the regulation and the associated standards. The Cyber Resilience Act and the machinery regulation. This machinery regulation is primarily looking at safety-related products. It's effective by January 2027, so earlier than that. And there's IEC 62443, the standard for cybersecurity of automation systems. And it's important to understand that the 62443 is not mentioned in the CRA. It's not mentioned in the machinery regulation either, but authorities are testing already according to 62443. And in the CRA domain, that's basically all we have right now. We are deriving European standards from the IEC 62443 right now, so they will look very similar. But the Cyber Resilience Act as such does not reference the IEC 62443. What are the requirements laid out in the CRA? And it's important to understand that the standard clearly says they have to meet the requirements under conditions which can be reasonably be foreseen, not under conditions which someone with a large fantasy can come up with. The processes also need to comply. So the Cyber Resilience Act not only covers products, but also the processes to develop them, to maintain them, to support them as well. And very important, in the Annex 1, the first point is products have to ensure an appropriate level of cybersecurity based on the risks, not based on their possibilities, but based on the risks. So this means it depends on how they are used, where they are used, what is the reasonably foreseen usage case of those products. And risk is always a combination of severity or the impact of a successful cyber attack and the likelihood. So if an attack is rather likely but not has low impact, the risk may be manageable. And if the impact is very high but it's extremely unlikely that such an attack happens, this can also be manageable. So it's a combination, and it's important to keep that risk-based approach in mind. The obligations for manufacturers throughout the product life cycle are very strict. So you have to report exploited vulnerabilities throughout the expected lifetime of a product. Now, what is the expected lifetime? That every manufacturer can define by itself. But of course, that's one of the key questions. It's very unlikely that you can get away with your customers if you define the lifetime of your machine for 2 years. So it has to meet the requirements of the customers, and throughout the lifetime of your expected lifetime, defined lifetime, you have to report the exploited vulnerabilities and incidents to the national authorities in Europe. The reporting obligations in a lower means also continue, but you also have to not only report them, but handle them as well. Important to understand that we're not just talking about components, such as whatever drives, IOs, etc., but components are used to make products such as machines. If you're a system integrator, you're selling a machine, a system to an operator, so that's a product too. So your product has to meet the requirements of the Cyber Resilience Act if your product ends up in the European Union, because it has to have a CE mark, and meeting the CRA is part of the CE declaration. In February this year, the Commission actually started a standardization request to develop 41 standards for the Cyber Resilience Act. 41. And the deadlines are very strict. By August 30 next year, the standards for designing products and for vulnerability handling have to be there. The standards for the product requirements have to be there by October. And by October 2027, we need the processes standards. So that's a very short time, and it's because those are harmonized standards. The process of getting harmonized standard is quite complex. It's quite likely that some of those deadlines won't be met. IEC 62443 is the standard on security for industrial automation and control systems, and it consists of many, many parts. I'm not going in details here. Some parts are still under development. They have different states in which they are in. The one we're looking at mostly is -3-3, which defines the system security requirements as well as security levels. So IEC 62443 is basically the international standard on cybersecurity for industrial automation and control systems. And the European standards will be derived from there. And I'm sure in the United States, a lot of customers, a lot of users refer to IEC 62443 as their, let's say, threshold or benchmark for cybersecurity. -3-3 expands the foundational requirements, the 7 foundational requirements, into a series of system requirements. So they go in more details. As an example, system integrity, foundational requirement 3, is expanded into 9 different system requirements. They go in quite a bit of detail. So overall, the system requirements, there's more than 100 system requirements in total that you have to meet. It also defines the security levels. Security level 0 means no security. Security level 1 basically means the protection from the viruses, the malware, the ransomware that's floating around in the web, but is not going towards your machine, but still we need protection for that. Security level 2 is protection against intentional violation. That is typically the security level that we can assume, let's say, the attacker that can come close to our machine may have. So for most machines and applications, security level 2 is the one we need to meet. I should say you don't meet a security level. To be precise, the security level defines the strength of the attacker, and we have to protect ourselves against an attacker which has the skills, the motivation, and the resources defined in those security levels. You see, security level 3 already has sophisticated means, whereas security level 4 is the attack by, let's say, a secret service. And the famous example of Stuxnet is clearly a security level 4 requirement. We typically don't see security level 4 requirements in industrial automation, in standard machinery and standard applications. So the Stuxnet example is not a good example to look at cybersecurity for machines. Let's be clear, if CIA and Mossad joins forces, has 2 years and an unlimited budget to attack your system, you're done anyhow. Another example, data confidentiality. We have the information confidentiality, and system requirement for that 3 defines the use of cryptography. Let's have a look at information confidentiality. It goes in more detail there, and for all the different security levels, for all 4 of them, information confidentiality is a requirement, as well as use of cryptography. So people who read IEC 62443 not in detail or not thoroughly may come up with the result that the CIA requires encryption of process data. Is that really the case? Well, first of all, it says only data for which explicit read authorization is supported the confidentiality must be provided. Explicit read authorization, it's very questionable if standard process data, such as command values for a drive, require explicit read authorization. So that's the first point. But then if we go in more detail, the rational and supplemental guidance for information confidentiality says that protection of information can be maintained through physical means, through compartmentalization or encryption, among other techniques. It doesn't say Data has to be encrypted so that confidentiality is provided. And if we look at the rationale for the use of cryptography, it also says the selection of cryptographic protection should match the value of the information being protected, the consequences, the time period, and the system operating constraints. So it doesn't mean by all means you need that. So the statement CIA requires of encryption of process data is simply wrong. It's not the case. You can meet the requirements of the 62443 without encryption by other means, and you have to look carefully if your data needs that confidentiality in reality or not. The goal we have, of course, is cybersecurity resilience. And just a picture I took actually in the United States in Santa Clara, California. A bigger lock doesn't always help. If the screwdriver opens this valve, it depends. It depends on your requirements. It depends on the environment. Or take this one here. Bigger lock doesn't help here either. This was actually taken in Ho Chi Minh City in Vietnam. And this is not KI generated or AI generated. This is a real picture from Guadalajara in Mexico. I don't know what's behind that door, but there's a lot of locks here. This may just be the situation that the shop owner says, hey, go next door, thief. There may be valuable stuff in there, but keep in mind that more locks not only add hardware costs, but they only add handling costs. So keep the risk in mind, don't overdo it. Keep the risk-based approach in mind. And it depends on, is the risk really that high? Can I afford the number of locks and the associated handling costs? And it doesn't make sense to demand or request every possible countermeasures, because if you overdo it, you just increase the costs, and systems become slower as well. If you introduce authenticated encryption, it generally eats up some of the performance or quite a bit of the performance of most technologies. So protection should match the likelihood and the impact of an attack. And the example of confidentiality, is it really important to make sure that your process data cannot be read by anybody? What would an attacker achieve if he did that, if he got that? And yeah, the risk not only depends on the device, but for sure also on the application. When we started talking with the notified bodies, we were looking at typical applications which we thought were good examples for either the left hand, the green, or the most difficult side, the right hand side. If you look at a control cabinet which is locked and which is air-gapped, not connected to the internet, for instance, this may be an industrial washing machine somewhere. The likeliness of an attack, the impact of an attack, very low. So probably no protection whatsoever is required. Security level 0 might be sufficient here. Security level 1 is already given by the air gap and the locked control cabinet. On the other hand, on the other side, we were initially looking at critical infrastructure, such as a water supply plant. When we talked to the notified bodies, to our surprise, they told us they don't have security level 3 or 4. They have security level 1 today. They would like more, but they can't get any more. So if you want to build a water supply plant, yeah, you have to accept security level 1 these days. That just shows you that it's not so obvious what security level you can expect even from critical infrastructure. We were then asking the notified bodies, what about, let's say, a nuclear power plant where you would expect the highest security level or highest requirement? Well, they told us nuclear power plant, security level 0, 0 cybersecurity requirement. Oops, why? Well, quite simply, nobody can access a nuclear power plant. The control system is truly air-gapped. Nobody can just walk inside and install some software or do something to the system. They have other means to protect their control system. So avoid overdoing. Look at real life to make sure your system is economical. Don't don't bring as many logs as you can possibly find to your system. Keep it simple, and even, yeah, complexity can even make cybersecurity weaker. I'll just give you one example. I talked to an ETG member, and they supply to the electric grid operators. And they told us that their customers are super sensitive about cybersecurity, and that they have in their plans, they have 3 perimeters to protect the central control room. But when they came there last time, each of the perimeter door, which usually needs something like fingerprint or camera iris detection and stuff like that to open, each of them was kept open by a magnet because it wasn't handleable by the operators otherwise. And when the maintenance guy walked through all the 3 doors, he ended up in the control room and found the folder with all the passwords for the plant, but nobody was there. It's just a nice example where too much cybersecurity may lead to less cybersecurity in the end. You know that, or you are experienced with that with regards to safety as well. If the machine cannot be handled by the operator anymore because it's too safe, if you understand what I mean, they will bypass the safety measures to try to get their stuff done and end up with less safety than they could possibly get. So keep things in perspective. That's what I'm trying to say here. If we look at cyber security resilience, there are 2 main aspects: the system architecture and then, of course, the protocol and technology features. The system architecture is quite often overseen or overlooked in that realm. And you may have seen the statement that the automation pyramids, which we're all familiar with, that they are so old school, so out, and we now need automation networks, smart automation devices. Everybody's talking to everyone, from sensor to the CEO, from sensor to the cloud, etc. I've never seen a CEO interested in sensor information, by the way. But this is the brave new world of meshed networks that people are trying to claim, and people are trying to use that as their requirement to use the same technology from sensor to the cloud, etc. But if we look at the system architecture, it actually matters. With EtherCAT, we believe in a clear separation of the real-time network from the factory and the line control network. If the system below, if EtherCAT is robust enough, and I will show you in a minute that it is, then it may be sufficient just to protect the northbound interface of the controller for cyber attacks, because the devices down below are not exposed to the outside world. If you have no structuring and every node is connected to everyone, then every node needs protection. Now you may say, well, then let's protect every node, but that means you have to include encryption, you need certificates expire, you need a certificate handling system. There's a lot of complexity you're adding to your system, and the question is, for what? Interesting enough, even the organizations that claim that mesh networks, the cyber security working groups, are now going back to compartmentalization, to zoning, to separation, and they clearly say this is not possible. It's not possible to have everyone connected to everything. So the automation pyramid makes sense, and we think pyramids are great, not out. We should stick to that architecture. It makes a lot of sense. I have to guide you through a few EtherCAT fundamentals before we can go into the cybersecurity features. Otherwise, it would not be possible to understand how we do things and why we do things the way we do it. And EtherCAT is a performance breakthrough. It's so much faster, and the reason for that is our unique functional principle. We could update 100 server drives every 100 microseconds if we had the CPU performance in our main controller to compute the data for 100 server access every 100 microseconds. So EtherCAT is extremely fast, and I'd like to explain the functional principle now, because that separates EtherCAT from all other industrial Ethernet technologies. Now, I use the analogy of a train. I use the Shinkansen because the Shinkansen in Japan is not only super fast, but super reliable as well. The train, of course, is the equivalent to the Ethernet frame. It doesn't stop at every train station. It keeps going. Now, imagine you're standing on the platform and you're watching the train as it goes by. you have the chance to see everybody who's in that train. Our train has a variable coach, car, or carriage length, unlike real trains where every car has the same length. And imagine now you're interested in the person sitting in coach or car 27, let's say in seat 14. You're watching the trains as they come through. When you identify that coach or car 27, now you count the offset to that person on seat 14, and you're able to remove that person from the train. Okay, that's where the analogy has an end. You can't enter or leave a train at full speed, but you understand the point. And this works not only with single people, it works with entire groups of people. You can empty the entire train that way and fill it up again in the same go. Here I have another slow motion representation of the same functional principle. And just let me mention this. I say it still says master and slave here. This is not endorsing slavery, and by all means, this is just the usual way a clear master-slave architecture was described. My slides in this respect are still old school. I hope nobody's offended by that. So what's happening here? The master, the main device, the controller sends out the EtherCAT frame, which goes through the sub-devices, through the slaves, and they extract data on the fly from that frame and insert data into the same frame. In doing so, they all share one frame, one bandwidth, they get maximum utilization of the bandwidth, and most importantly, you don't see switches here. So this is not only super fast and leads to the enormous performance of EtherCAT, it has many advantages with regards to cybersecurity as well, as we will see in a minute. Here I have another representation of that frame. The EtherCAT header is inside the Ethernet payload, and then you have datagrams inside, which are basically the coaches or cars, and each of them has a header and then all the data in there. But we don't need an address on a per node basis. We only address the entire car or carriage, and then everybody knows by the offset towards the beginning of that car where his data is located. So we can have now decentralized I/O. We can have single bits on the EtherCAT system without wasting an entire frame for that. The performance is maximum and predictable because our communication is entirely handled in hardware. We need special EtherCAT chips on the sub-device on the slave side to do that inserting and extracting on the fly. And we don't have switches. That means we don't have the cyber issues related to switches either. We have very nice diagnostic features as well, but we won't expand on those in this presentation today. Synchronization is very important. It's important not only for multi-axis applications such as robots, but even if you want to control a single servo drive, keep in mind the drives doesn't give you velocity, it gives you position. The encoder is a position sensor. And so you're computing velocity out of position readings. If the position reading is jittering, the velocity you get is wrong. And how can the output be good if the input is wrong in the first place? So even if you want to control a single servo axis, you need precise equidistance, precise synchronization of your system. And with EtherCAT, we use the principle of distributed clocks. That means one of the sub-devices we use as the master clock. We measure the propagation delay between the master clock and the subsequent devices. And based on that information, we can now align the clock time between all the nodes, which means they now act on when the clock reaches a certain time rather than on when the frame comes along. That means we have synchronization throughout, and the master can jitter a little bit because it doesn't have any impact on the actuation and the sampling of the data in the sub-devices. This is a very important feature, and we can also make use of that for cybersecurity measures. And just to show you how precisely we can do that, this is a system with 300 nodes and 120 meters of cable, sorry, about 350 feet of cable in between. And you have the first interrupt and the last interrupt. And the jitter is just plus minus 20 nanoseconds. That's not microseconds, nanoseconds. So that's the speed of light of about 6 yards. Also, you see the simultaneousness, which is the propagation delay compensation, same order of magnitude. So now we have no sampling error anymore due to jitter and we have very precise inputs for our motion control algorithm, and of course, also very precise synchronization of multiple access of test and measurement applications and wherever you may need synchronization. EtherCAT is industrial Ethernet. We can, of course, send any Ethernet-based, TCP/IP-based protocols over EtherCAT. We can use all the internet technologies when we need them. And we're not restricting the real-time capabilities because we're tunneling any other protocol through or over EtherCAT. And tunnel entrance is called a switch port. It's not a switch. But here you see fragments coming along over the EtherCAT system, which are assembled by a microcontroller and sent over the Ethernet port. Incoming frame can be chopped up and sent over the EtherCAT frame without slowing down the EtherCAT frame. The main device, the master, the controller, just assigns the bandwidth that is available to that tunnel entrance, basically. The protocol we're using here is called Ethernet over EtherCAT. This will also play a role in our cybersecurity considerations in a minute. Yeah, it's industrial Ethernet, so we can, for instance, talk to a web server that is on a remote device through such a tunnel entrance. We can send data to a printer through the EtherCAT system. But of course, EtherCAT itself cannot protect the web server, or it has that's out of scope for EtherCAT, protect the web server from cybersecurity attacks, which means you can use and you have to use all the classical IT measures to do so. EtherCAT doesn't care what kind of traffic you're sending through the EOE, through the Ethernet over EtherCAT tunnel, but any traffic through that tunnel cannot attack or influence EtherCAT at all, because EtherCAT doesn't look at that traffic, it's just conveying it. The architecture is so flexible that we can do the line topology. We don't have the issue of cascaded switches. We can do drop lines, we can do star or trees, and any combination hereof. The only limitation is 65,000 nodes per segment. If that's not good enough, open up a second segment. We use copper or fiber and standard Ethernet cabling. It's a standard Ethernet physical layer. The main device, the master, just has an Ethernet port, nothing else. So we need less hardware than other industrial Ethernet technologies. First of all, no switches. Very important with regards to cybersecurity, but also with regards to complexity and with regards to costs. You don't need IT know-how to set up any routers or anything like that either. The main device doesn't need any coprocessor, so we don't need a plug-in card or any extra hardware there. All we need is software and a standard Ethernet port. Excuse me. And on the slave device, on the sub-device side, we use those inexpensive slave controllers, as we call them. And why are they inexpensive? Simply because there's so many. You can say that the EtherCAT functionality is meanwhile commodity in the semiconductor world. We have more than 50 different chips available which support the EtherCAT sub-device, the EtherCAT slave side of things, and there's more coming up. And you see the giants of the chip world supporting EtherCAT throughout their products. We started with very expensive chips on the left-hand side, the FPGAs for the first EtherCAT implementation. They were $80 each. Meanwhile, on the right-hand side, we're undercutting field bus cost levels with EtherCAT, not speaking of other industrial Ethernet technologies. And the reason simply is healthy competition among the chip makers. That's because EtherCAT is a world standard. The EtherCAT Technology Group is the world's largest field bus organization. We have more than 8,500 members now from 78 countries. Members means not people. You can't join as an individual. You have to be a legal entity to join, so a company, a university, or like. And this shows the growth of the EtherCAT Technology Group. The blue line is the 12-month growth with the right-hand scale. And you see that for over 10 years now, we've constantly grown with more than 400 new members every 12 months. In the last year, actually, it was close to 600 new members. Membership is free of charge. If you're not yet an ETG member, please send an email to info@ethercat.org. So you're interested in membership, and we're happy to provide you with information. This is the membership distribution. You see on the left-hand side, this was the group of founding members, 33 to begin with, predominantly from Germany and Europe. And meanwhile, you can see that Asia has the largest chunk, more Asian members than European members. Americas looks weak with 14%, but that's not true. 14% means more than 1,000 members in the Americas, which makes us America's largest FeedBus organization as well. So you can see we are truly global. We're not just a regional organization with a few overseas members. The node count for EtherCAT looks like this. By the end of last year, we had 88 million nodes deployed. That makes EtherCAT the world market leader among all other industrial Ethernet technologies. And you can see that in the last couple of years, the growth was enormous. This was the time when the chips were short. The chips were in high demand and not enough supplies. The chip shortage was there. And many users understood that with the current FeedBus network and with the current supplier, there's no plan B. Whereas with EtherCAT, there's plan B, C, D, E, etc. So that was a big push for EtherCAT, that very severe situation we had on the supply chain. How accurate are those numbers? Well, they're based on chip licensee reporting information. So nobody exaggerates those numbers. It would be costly to do so. We don't know the FPGA implementations among those though. So we assume they're less than 10%. That's very conservative. Most likely it's way more than that. And we also count multi-protocol chips only according to their market share. Yes, we count chips, so there may be a certain time lag. But whereas these are 86 EtherCAT devices, we count them as one node only, to be fair in comparison with other industrial Ethernet technologies. Yes, I do know that some so-called market research companies have a different view, but yeah, that's the main reason is we only started publishing our node counts 2 years ago, and they would have to admit that all their previous figures were so strongly out that they have difficulties adjusting now. By the way, when I said chip licensee reporting information, just to explain that, the license model of EtherCAT works like this, like with the CAN technology. The license is embedded in the EtherCAT chip, which means there's no fee for the license that any device maker or any user has to pay. And that small amount of money that is embedded in the chip goes back to the licensor. In that case, Beckhoff invented EtherCAT and is the licensor. And Beckhoff uses that funding to fund the EtherCAT Technology Group. In other words, the ecosystem is paid for by that license. And that means we can provide the information, the access to the technology free of charge to users, to device makers, etc. throughout that model. So that whenever anybody buys an EtherCAT chip, the license is embedded and is there already. Very important is the versioning history of EtherCAT, because this is not the versioning history of EtherCAT. We don't have one version every year. There's only one version of EtherCAT. What does it mean? It means we have never changed the technology. We've enhanced it, but we never changed anything. By the way, the versions in the background are Profinet. So with EtherCAT, you can take a device of today, put it in a network of 2004, it will still work. Don't try that with any other industrial Ethernet technology except Modbus, which hasn't changed over 30 years now. But there was also no add-on there. With EtherCAT, we've never changed things. We added features, but we kept everything as it was once it was released, which means you don't have to worry about maintaining old FeedBus networks with EtherCAT. You don't have to worry about the protocol version that was used back in the days, the firmware and the firmware download tool, which only works on Windows XP. And you don't have to worry about the hardware that can still play that old or use that old firmware version that you may have found somewhere. No such issues in the EtherCAT world. By the way, that's a good enough reason for many users to go with EtherCAT, that alone. So let's have a look now at the cybersecurity features. And some introductory remarks to that section. I'm not trying to play down cybersecurity at all, but those who claim that their system is unattackable, they either have no idea or they're simply lying. Let's be clear. It's not a question of can it be done, it's a question of how many resources, how much know-how do you need. Any system can be attacked if you have sufficient time, sufficient resources, sufficient energy and motivation. So it's not a black or white situation, it's a gray situation. But systems can be robust enough. For instance, if the resources for an attack are simply not available to the potential attacker, or it just makes no sense for him to invest that amount of time and money to stop the machine, if that is his goal. It may also be a good idea to be much better protected than your neighboring system. Most likely, the attacker will choose a different path then. It doesn't protect you entirely though, but with keeping the risk-based approach in mind, it certainly reduces the likelihood. I don't know if you know the story about the two friends hiking in the bush in Africa somewhere, and one brings his running shoes, and the other guy goes, "Why do you bring your running shoes?" "Well, if the lion attacks, I can run faster." "You're such an idiot. You can't outrun a lion." "No, surely not, but I can outrun you." Maybe it's sufficient just to be faster than the other guy. Of course, if there's two lions coming, you may have a problem. So it's not sufficient, but it reduces the likeliness. We have to distinguish two main attack vectors. One, the attack from the outside, the remote access to the network. And then there is the inside attack, someone who has physical access to the network. Those are two extreme different animals. And keep in mind, if somebody has physical access to the network and his goal is to bring down the application, to bring down the machine, there's much cheaper, much easier ways to achieve that goal. I'm not saying that's like the two guys in the bush. It is not full protection, but it reduces the likeliness of a physical attack through a cybersecurity. And that has to be kept in mind. Malware needs the internet protocol to travel. I'm a sailor, that's why this picture here. So if there's no internet protocol, a virus can't get past the next router because IP is for routing. So there is no, or basically no virus, no malware, no ransomware under the internet protocol. It's always above the internet protocol. It needs IP. Otherwise, it wouldn't get past the next router. It would starve in the subnet. But EtherCAT is not using the internet protocol. We're not based on the internet protocol. We have our own Ether type, so we're directly embedded in the Ethernet frame. Furthermore, the next header that comes is the EtherCAT header, and in here we have a certain EtherCAT type as well. And the subdevice, the chip, can check two levels if that is an EtherCAT frame or not. And this is what it does. It actually checks every frame that comes through if it is a native EtherCAT frame or not. And if it is not, the frame will be dumped. It will be destroyed. In other words, you can take an EtherCAT subdevice, bombard it with your entire malware collection, nothing will happen, zero. It will drop all the frames one after each other. You can try to overwhelm it with a denial of service attack, nothing will happen. Of course, if you are removing the main device and putting in a device that's only sending nonsense, the system will shut down. But you can't attack in terms of cybersecurity that way. So that's the first and foremost, the most important protection we have. Any non-EtherCAT frame is filtered out in hardware. Can I attack by adding a sub-device, a slave device? Well, if you are on site, if you're able to sneak in another device, connect it and power it, well, you can possibly do that. It's a physical attack. It requires access, but the sub-device can't do anything. It won't be able to listen. It won't be able to talk unless the main device actively enables it to do so. The chips are also designed in such a way that never ever a sub-device can listen to traffic which is not intended for him, or never send a frame either. The hardware can't do that. It can only modify the frames that comes along, and only those who are truly EtherCAT frames. Plus, we can lock the ports, shut them down that we're not using, so there's no open port remaining in a properly configured EtherCAT system. So plugging in another device, well, you can plug it in, but nothing's gonna happen. It's disabled in hardware. So can I modify a sub-device? Well, the chip that as I just mentioned, doesn't have access to the registers which enable the communication. It doesn't have write access. It can read those, but not write. This is a hardware property. In other words, it has no access to data not intended for him. Even a device with a corrupted firmware cannot change that. It's simply not doable. Can I build a dangerous sub-device? Well, if you have enough resources, enough time, it's several person years of effort would have to design a chip with which has that intention to corrupt frames for others. I'm not saying it's impossible, but it's extremely unlikely because it's very inefficient attack vector. Of course, our main devices are masters. They do need protection, regardless which field bus we're using. It doesn't matter at all. So if somebody takes over your controller and changes the application code, you're done. I mean, regardless what cybersecurity features you have employed down below. So by all means, the main device, the controller needs protection. And that is regardless of the field bus, regardless of EtherCAT, even if there's no field bus at all, you need to protect that device. But that's beyond the scope. To attack the scope of EtherCAT. To attack an EtherCAT network, you need physical access to do so. And if physical access is provided, there are so much easier, cheaper, and simpler ways to do harm to the system, which means they have a higher likelihood. How about the Ethernet over EtherCAT protocol that I mentioned earlier? Well, it isolates the real-time traffic from standard Ethernet traffic, so you can't intrude by sending malware through that Ethernet over EtherCAT channel. But of course, you can, in principle, attack the end device that unwraps Ethernet from the EtherCAT system and then makes use of that whatever Ethernet frames that come along. So if you're concerned about that, well, don't enable it. It's disabled by default. You don't have to use it. Or you could configure your system in the first place and then disable it so nobody can change the configuration. So you see, EtherCAT is inherently already very robust against cyber attacks. And for the basic risks up to security level 2, you don't need to change anything, and we don't have to change anything. EtherCAT as such, through its general functions, offers sufficient protection already. There are many of those features, I mentioned only some of them, that we use for cybersecurity, such as destroying non-EtherCAT frames, such as closing down the unused ports, such as checking what kind of devices are out there during boot up, such as the advanced diagnostic features, etc., etc. So there may be applications which have an increased risk, like security level 3, and they may require additional measures, sure. And yes, we are currently specifying those enhanced measures inside the EtherCAT Technology Group. The good news is it looks very promising that we can fulfill security level 3 without any changes to the sub-devices that are on the market today, to the slave devices. It will be software only in the main device. So even security level 3, you can meet the requirements without changing anything to EtherCAT devices that you find on the market today. One example that we're integrating there is the integrity of the slave device description files. So we're currently bringing up a certificate authority inside the EtherCAT Technology Group so that the vendors can sign their ESI files. So you know that the ESI file comes from where it should come from and not from some different source. We think that's a very low risk though, because the ESI file is read only once at the beginning of the configuration. And if there's a bug, if there is a default change in that ESI file, well, then the system acceptance test will unveil it because the device behaves differently than you expect it to behave. The ESI file is not read every time, is not read again after the commissioning phase. So we think that risk is low, but some people want to see a signed ESI file. Well, if they want to get it, they will get it from EtherCAT Technology Group. There are applications which also require confidentiality. Yes, we think there are very few that actually do that, but we also prepare extended measures for that purpose. This requires protocol extensions on both ends, but as far as we can say, those are no hardware changes, which means a firmware update will do on almost all devices. There may be some devices which need additional memory or something like that. I'm not promising that every existing slave device can be upgraded to that, but it will be software only. So we are working on that extension. The challenge we have is that cybersecurity is typically addressed by IT people, by people with an IT background. And they are used to the, let's say, mechanism that they ask for certain countermeasures rather than looking at the risk first. So the cybersecurity default is like, we need denial of service protection. Where's your specific denial of service? Where's your authentication? Where's your encryption? Where are your certificates, etc.? And this is a little bit like somebody that wants to discuss the diesel particulate filter with you, but you are having an electric vehicle. But they insist on a diesel particulate filter and on the features of that. And you say, but I'm an electric vehicle. That is the challenge we sometimes have. We have to show to the IT security people that their IT measures do not necessarily apply to EtherCAT because we're different. We're like the EV among the diesel networks. You have to take the special features, the special cybersecurity features of EtherCAT into account when you assess the system. And assessing the system is what we're doing right now. We are working with the TUV and with other notified bodies. And actually, we published a press release recently stating that EtherCAT meets the CRA requirements, meets security level 2 of IEC 62443 without modification. And TUV has stated that our arguments are correct and that they support this press release, support this statement. So we are meeting security level 2 already. Security level 3, the measures are currently being defined and they don't require any hardware change. In most cases, a software enhancement on the main device will do. We are working with the TUV right now for the assessment report and expect to have that in Q1 next year. And we're also working with other notified bodies to get a second opinion on that. And that means that we're not just coming up with a statement on our own behalf, but we have the support from the experts that will also do the certification of the products later on. So we are also members of the standardization working groups that are currently writing the standards that will be relevant for the CRA. So we know what's coming up and we are also actively contributing there. It's important that IEC 62443 for CRA is a good start. For the United States is certainly the benchmark that you have to meet, but don't misunderstand it. Don't just go to one table and say, hey, there's a check mark at, for instance, encryption, so I need encryption throughout. No, that's not the case. Well, that concludes my presentation, and we have a few minutes left for any questions you may have. And also, please check out these QR codes here for the blog and for the suggestion survey for the topics for next year. Damon,
Right
Cameron is around. Cameron has been watching. Are there any questions that anybody may have that we can address today?
So a couple questions along the way. The first one you addressed at the end. It came in beforehand, but basically it was, have any third parties checked the claims that EtherCAT security meets security level 3? Basically our claims, but you addressed that with, you know, the TUV has looked over it with the press release, and I believe you said there's some other third parties taking a look at it at the moment.
Yeah, we don't have the assessment report yet. We're in the final phase, but the TUV has approved the press release that we just published, and sure we can meet security level 3 with EtherCAT. The good news is without hardware changes.
Yeah, great. Other one was, EU's the Cyber Resiliency Act affects the EU, obviously. How does this affect U.S. machine builders, their selection of field buses used in the machine?
Well, if your machine at any time may go to the European Union market, then it affects you directly. If that's not the case, if you're just selling outside of the European Union, the CRA directly has no direct impact on you. But cybersecurity, cyber resilience definitely has. And your customers will definitely require certain security levels that you have to meet. And we do, as I tried to point out, use IEC 62443 at this point to show our preparedness, our readiness for CRA. But this is exactly what you need in the US market to prove to your customers that EtherCAT is meeting the cyber resilience requirements, regardless of the CRA, without any additional nightmare and without any additional problems.
Great. Okay, so we're down to the last couple of minutes of the webinar here. If it looks like there's a few more questions we can address offline, and I'll give some little bit of closing thoughts. So, I mean, if you have any other questions about this or EtherCAT in general, the cybersecurity effectiveness of EtherCAT, please reach out to your local Beckhoff contact, your local Beckhoff representative. And you can, a little bit of that contact information on the screen. You can also look it up on the website and look for the local regional person as well. And as Martin already mentioned, there's a couple of QR codes on the screen. One's a contact us from our blog form, and the other one is suggestions for upcoming webinars. So if there's other things that you'd like to see us do or topics you'd like to hit, please let us know. So big thanks. Yeah.
Sorry,
yes,
I just saw one message, one question here I would like to address. The question is, is there a published hardening guide for EtherCAT networks? Not yet. We won't make a hardening guide because we will show what you don't need to do or what you need to do, yes, to reach certain security levels. You can consider this a hardening guide. We have plans to come up with a white paper first, beginning, let's say, in the early phase of next year, based on once we have the result from the notified bodies. Because, of course, that is the prerequisite. We don't want to make a statement on behalf of EtherCAT Technology Group alone. We want to give you documentation that really helps you, that you can also use to argue towards your notified body when you get your machine or a system approved. Then we will have a guideline coming up, and of course also the specifications for those that implement the additional features. This will take a little bit. Won't be available like in the first 2 months or so. This will take throughout the next year, but will certainly be in time for everybody that needs to meet the CRA.
Great. Good. All right. Well, I guess in closing thoughts, I appreciate everyone joining us today. Martin, thank you so much for joining us from Nuremberg, for your expertise and presentations. Any closing thoughts from your side?
Yeah, well, as Damon mentioned, this is not exactly the time when our Christmas party starts. And since we are here in the beer capital of the world, 25% of the world's brewery are within 100 kilometers from where I sit today. So you can say
so
why
it should be a good Christmas party?
Sorry?
So it could be a good Christmas party?
So you can bet it's going to be a good Christmas party. And having said that, thank you for watching, and all the best for you guys.
Perfect. Thank you, Martin. And everybody else, look for our upcoming webinars. Thank you so much. Bye, everyone.